like how do you sort your data? How do you clean your jumbled up data set? And how do you actually paint a picture with that data? So that's the entire pipeline of a data architecture. Now, giving like a software engineer kind of a example, like if you have ever used a chat application like a Messenger or Google Meet, like you send out a message and then you expect that the person whom you're sending it to is getting that message itself and nobody else is getting that message. How do you in the back end build that system where you have full confidence of whomever you are sending the data to is actually getting that data? So it has a lot of things which are working in the background. How do you store the data, the latency of the access of the data, and so on. So there are so many small nuances which go in the background. Everything together is actually data architecture.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Anjan Banerjee is a data architect. Today we are talking about building complex AI in data systems. Learn how AI is being used for data processing, model training, and how you can embed intelligence directly in your data pipelines.
So basically, a 5-year-old version is like when you have a lot of Lego pieces in a box and you don't know what to do with it. And you eventually start sorting those Lego pieces into color coordinated pieces and then build structure or a castle with it. That's what actually data architecture means like. Like, how do you sort your data? How do you clean your jumbled up data set? And how do you actually paint a picture with that data? So that's the entire pipeline of a data architecture. Now, giving like a software engineer kind of a example, like if you have ever used a chat application like a Messenger or Google Meet, like you send out a message and then you expect that the person whom you're sending it to is getting that message itself and nobody else is getting that message. How do you in the back end build that system where you have full confidence of whomever you are sending the data to is actually getting that data? So it has a lot of things which are working in the background. How do you store the data, the latency of the access of the data, and so on. So there are so many small nuances which go in the background. Everything together is actually data architecture.
And what I'm seeing nowadays is that in comparison to back in the day, you have so many different pre-built components you can use, which are open sourced or managed services by different companies, that it is really like Lego bricks. You're basically taking the different components off the shelf, you're putting them together, some you're programming yourself, and nowadays it's often like you have to act smartly from the beginning and really decide where do you pick your battles and where it's really necessary to code something up yourself, where you actually have a competitive advantage and where you just pick off the shelf components.
You're absolutely right. Like, I would say that when you buy a Lego set from a shop, and those Lego sets actually come with instructions. But when you combine two different Lego sets and you build something of your own, sometimes the wow factor is present when you have created something of your own, but it may not actually work so well, or it may not be a stable structure or something similar to that, right? So there are so many off the shelf products right now, but you need to know how you actually bring them together, how you integrate what tools together effectively to make a structure which is stable. I'll give you an example. Like right now, there are new tools which are coming up for ETLs, data extraction, doing change data capture. Like one of my favorites right now is Airbyte. Airbyte is so good when it comes to doing CDC from sources, and CDC is change data capture, which is when a source has a change, you would want to move that data immediately to a warehousing solution or your storage. So Airbyte is so good, but it is very rare that I have seen people use Airbyte effectively in their existing stack. So knowing what Lego piece to use where is also a skill to have. I have seen multiple organizations actually struggling to do that right now.
And that's especially, it's so understandable in my opinion as well, because there are so many different components for each different piece of the stack. So you have like your entire system, then you have the different components, and it's like exploding in complexity because there are so many different offerings right now. So if you think through developing a data architecture, what are your main components you see if you look at the entire system, and how do you think through them, and how do you connect them together?
So the basic component where I start, the moment I am being asked to create a data architecture, step one is to identify what sources do I have, because every organization has different types of source systems. Now, what does source system mean? Like, let's say a manufacturing company will have shop floor data, a social media company will have device data, a healthcare company will have research data. Now, these kind of data sets are actually sources for us when we are actually designing a data architecture. Now, few of them will be updated once a day, few of them are streaming data sets. So step one for me is to identify what kind of data sets are available for that organization. And then we will actually try to figure out the best tool, what we can use to extract that data. And usually it is really good to have one single tool to do most of the activities, because right now in the market we have seen that there is no single tool to do all of these activities right now. So it is always good to have one single to do most of these activities. Then comes the business use case. Like, why would an organization want to consolidate all the data, pull the data out of their source systems? Do they want to build a data science model or run, let's say, a large language model to train a model on the organization's data? Then you would want to store that data in, let's say, block storage. Or let's say if you have a lot of images and audio files and basically non-structured data, then you would want to store it in a block. But if you have, let's say, a lot of time series data, then telemetry data, then you would want to store those data in a time series database. So it all depends on what the use case is and what the organization wants, and then we decide the storage engine. After that piece, then the utilization of the storage engine. How would you actually store that data? A lot of cases where relational data needs to be stored in the object store as well, then you would want to have, let's say, an open table format like Hoodie or Parquet storage or Delta Lake formats, and all these different types of formats store that data in the object store and then utilize it for your machine learning use cases or for your training purposes of your model. Basically, starting from what sources you have, what is the use case, what you want to implement with it, and then you decide the exact tech stack to it. So your relational, non-relational, semi-structured, structured data, everything needs to actually be coming together. And the recent market, what we have seen is that the multimodal kind of storage engines are actually picking up trend, because back in the days, you used to have very curated data platforms. So if you had relational data, you would only store it in a relational database. Now you can see that there are multimodal, like Snowflake has started coming up with their own version of it. Databricks has started coming up with their own version of it. BigQuery have started coming up with their own version of it. Multimodal, where you can store multiple varieties of data in that storage engine.
Yeah. And also one more trend which I'm seeing, which is in a very similar vein, is actually trying to put a structure on top of your structured data. So storing in a table, for example, if you have images with bounding boxes, you're storing the structured information in a table with a reference to the specific image, so you can speed up the processes down the road and have as much of the additional information and the information which can be structured in a relational database, and instantly can reference the images, which gives you like a best of both worlds. You can filter pretty quickly on the relational database and then get the images directly through the reference, which solves like the pain point where you have to search through a lot of, like, for example, Parquet files or compressed images, which is often not that pleasant to do.
Absolutely. And we call it in the data ecosystem, it's called as tagging. Like, how do you tag a particular image frame with the exact things what you just mentioned? Blocks of, let's say, the object identification. If it is a car, if it is a truck, if it is a street sign. I'm just giving an example from an automotive standpoint. But what we do is store the metadata from these objects in a relational format with the reference to the tag, with the reference to that image itself. Now, we do that with video clips as well, frame by frame, how you can actually create tagging for every single frame of a video recording. Now, another thing which we have seen, I'm going back to automotive because right now the unstructured data is really, really heavily used in automotive and self-driving cars and so on, is that when you are actually recording a lot of video information when a car is actually driving, how do you actually compress those video recordings in a lossless fashion so that the model on which it is doing the self-driving can actually effectively work? Because a car at the end of the day will have limited compute resources on board. So you would want to have very optimized models and optimized compression done and optimized tagging done of these video frames so that these models are effectively run. Now it goes same for like healthcare industry. Right now we have seen that doctor in Europe is actually conducting an operation with, they call it the 5G, with the 5G technology and the lag free video transmission, that they are actually controlling a robot hand in US and the doctor is actually sitting in Europe. So how do you do that? The videos which are reaching from US to Europe are compressed in such a fashion that it is not actually losing any details. So these are things which are actually really, really picking up, like frame tagging, lossless compression, and identifying how to train a model in the edge location effectively.
Yeah. And if you're looking more on the data architecture and like the more data components you have, like data storage, data processing, data ingestion, data orchestration, and then the deployment part of the microservices as Kubernetes, when do you start thinking through the different components and how do you choose certain tools for each of the different steps? You already mentioned you want to try to get one single tool to do most of the activities. So, do you have a preference for something like Airflow, which has just such a development history that it can cover a lot of bases? Or do you also like going with like some of the newer tools which are more restricted in their capabilities?
So personally, I like Airflow, but I would rather go for a specialized tool. I'll give you an example about having the transformation done using dbt on the database itself rather than writing my own code in Airflow. Airflow has kind of large learning curve when it comes to building complex data ecosystems. Now, if the organization whom I'm working with has a set of good developers, Python developers, and like data engineers and data scientists in house, then I would definitely go for Airflow. But let's say, hypothetically speaking, the organization I'm working for does not have those kind of people available, like the skills available in house, then I would rather go for something which is more of like a UI based ETL or orchestration tool, which will make sure that the learning curve is simpler for them. Let's say, for example, likes of Talend or Alteryx or Informatica, where the learning curve is lower and easier for people to pick it up. So they just log into a cloud SaaS platform and then they can build their own pipeline. But if they have Python developers, I would definitely go for tools like Airflow. Now, organizations like Amazon has started releasing their own flavors of Airflow, or even Azure has now integrated Airflow in their Azure Data Factory or their pipeline engine and so on. So Airflow is a versatile tool, and that is the reason why it is being integrated well. But there are certain limits of Airflow as well. That's why when you actually push the limit of how many DAGs you can actually have, DAGs is like the pipeline what is created within Airflow. So how many DAGs you can have on Airflow and so on. So to an extent, Airflow is good. But in one of the big pharmaceutical companies where we were actually using Airflow, we quickly realized the limits of Airflow, and then we went to another tool which is called as Luigi, which is, if I'm not mistaken, is released by either Facebook or LinkedIn. It was either of the two, but they released Luigi, and we were using Luigi because the limits were higher for that. So it's been quite some time I used Luigi, but we really were able to effectively use Luigi in that case, and we moved out of Airflow because we had that limitation. But for another company, which was semiconductor company, where we actually used managed Airflow, which is Astronomer, the actual company which actually built Airflow, they now have a SaaS option as well. That was Astronomer, and we were using Astronomer, and it was working absolutely fine. So it also depends on the industry and the limits of how much you want to utilize tools. Now, coming to the exact question what you asked, like what is my preference which with regards to what tools I would rather use, me being a technical person, I would go for specialized tools. But that doesn't mean that I'm going to propose the specialized tools for every single organization. I need to understand what the exact skills what that organization has, so that the uptime or the actual cost to run the platform is also lower for them.
One issue I often see in Airflow is that it comes with an overhead that you mostly have to deploy Kubernetes clusters. And for me, I'm missing a little bit the ability to use serverless functions, which are managed by one of the different providers. Have you seen any orchestration tool which allows you to go more into the serverless direction as well and integrate, for example, Lambda function or Cloud Runs?
So for AWS, let's say, since you mentioned Lambda functions, I'm actually going into Amazon specifics now. Like we have tried 4 different flavors to orchestrate on AWS. Have Kubernetes like a Fargate instance for Airbyte, then have managed MWAA, which is the managed Apache Airflow for Amazon. Then what we had was step function. We use step function, which is the native AWS orchestration one, and also Astronomer, which is the SaaS offering of Airflow. We found out when we talk about Lambda functions, step function was the most effective one. Now it is again managed service. It's kind of serverless. You don't have to do anything about it. It's just you create the workflow of how the code needs to be triggered one after the other and so on. And that worked really well. Now going to Cloud Function, Cloud Run was actually more effective than using any other tool what we have seen. So what I'm trying to get to here is that when we actually ask something which is a cloud service provider specific, then their native services sometimes outperform these third-party tools. So step functions, well, 2 years ago, if you would have asked me that should I use step functions, I would have said no. Now, if you ask me, should I use step function? I would say yes, give it a try because it is getting better and better incrementally. Same goes for Glue, AWS Glue. 2 years ago, if you would have asked me, should I use Glue for my pipelines? I would have said absolutely not. It's a money burning tool. You think that Glue is going to be cheap? Absolutely not. But now with integration of Glue Data Brew, Glue workflows, Glue pipelines, and even a GUI, which actually helps you build Glue jobs with drag and drop features, that also gives you like a serverless kind of a framework where you actually propose the DPUs, which is the data processing unit of Glue, and then you start building pipelines. That's also serverless. You don't define or configure any servers, and it's easily scalable. So you provide the least number of DPU utilization and the max number of DPU, and based on the utilization, you get billed. So it absolutely depends on the particular use case and the cloud service provider what you are working on. And the only problem is that you tend to get locked in. What I mean by that is that if I use step function, now tomorrow, if I want to experiment with something which is in some other service or some other cloud, I can't use step functions anymore. Or I will have to create my custom script, create a Lambda function, write my code to trigger something in a different cloud provider, and then use step function to it. In those scenarios, when you are working with multi-cloud environment, I would still go for SaaS offerings of Airflow or even Prefect, which is the astronomer and Prefect, and even Airbyte, which is also a SaaS offering. You can have a self-hosted Airbyte, you can have like a SaaS offering of Airbyte. So those are things which I would rather use when you have a multi-cloud environment. But if I have a cloud specific one, then I will go for their native services.
And if we're moving into like more of AI, because in AI, I like serverless function because I often cannot predict the load I'm getting on certain components. And it's also very hard to manage the auto scaling or scaling of AI if you don't have an MLOps team. So the serverless part, it's a great part because you basically can hand it over to one of the different providers or an entirely different one. How do you see the integration of AI actually into more of the data ingestion and data processing? And that's, I think, one of the things that's coming more and more and becoming more and more obvious, that we are calculating embeddings, also doing classifications and tagging more in the beginning of the data acquisition process rather than at the end.
Yes, you are exactly right when you talked about in the beginning. I'll take your example itself of images. Like if you, let's say, have a camera which is constantly taking images every 10 milliseconds, similar to that frequency, and there is no change in the frame of that image which is taken one after the other, then do you actually ingest all the frames wherever there was no change effectively? Or you only capture the image which had a change detected and then move that frame into your data processing pipeline. So you have certain level of computation which is happening at the data generating point itself. And that is where we also feel that specifically ML is actually having a very key role in those exact scenarios where you have a lot of data generated and you don't want to specifically move all the data to your cloud service provider because storage is cheap, but petabytes of storage is also expensive. You don't want to store petabytes of data in your cloud. But well, it's still cheap to store petabytes of data on your cloud. But then processing that petabytes of data and then moving it for your machine learning purposes or your training your AI models, it gets even more expensive after that. So that's where like tools like ML Flow or Kubeflow comes into the picture, where you can actually have like a proper ML model getting trained, and you have Kubernetes clusters or like small Docker containers which get triggered based on the volume of data what is present. Now, coming to the source side of the things, you have tools like TinyML and Kube Mini or something similar to that, where you have mini Kubernetes clusters also running on your edge device, where you can have more and more models which get triggered based on the exact image or video what is getting captured in that edge component. So we have seen varieties in the market right now, but it also depends on the exact specific industry. Like for drone industries, you will have a tiny ML which is running on the drone itself. And that's how the automated device collision or object identification happens on the device itself. So those are tiny ML stuff. And then once you have that, then the video feed actually goes to your handheld device, how you are driving, or your headset, how you are driving the drone with. So these are all the things what happens right now.
And looking at the orchestration and more of the data processing side, how do you choose like which tools to use? Because in data engineering, the default still seems to be Spark. So deploying a multi-node cluster, which does most of the processing work, where there are already a bunch of managed services on all the big cloud providers, which you can use for that. But at the moment, there's also a trend to more like single node engines, like DuckDB for an in-memory OLAP database, or something like Polar's Data Fusion or the Rust-based processing. Do you think we will have more of a trend towards like TinyML as well on the cloud, where we actually try to break it up into mini batches, or even more like user specific AI, like what we already have in recommendation system, that it's more user specific, and we also run it on microservices just in a lot of mini batches?
So, to an extent, both. And the reason why I said both is because of industries. TinyML, I have seen, is more prominently used in manufacturing or more industrial setups. And it is actually really, really picking up because it's effective and it is light in computation. And you can actually run it in smaller devices like your ESPs as well. Well, ESPs is going to be tough, but your Raspberry Pis and stuff like that, you can actually run it. But when it comes to micro batching with regards to user recommendation and let's say targeted marketing advertisements and all these kind of stuff, that's where the batch processing comes in on the cloud itself. So you have that feature as well, but it is just for a specific industry, and TinyML is going to pick up for a specific industry. But both are some things where we should concentrate on because you never know how the industry is going to change or how the industry will look like in 5 years time, where we might even see some batch processing requirements for these manufacturing industry as well. So yeah, both.
And moving more onto the storage side, it's at the moment we have especially like the lakehouse taking off a little bit. Like we've seen Iceberg, we've seen Hoodie, we've seen also Delta Table, especially by Databricks, which are capturing a big chunk of the market. What are you looking at in a project, like more of the data architect view? What are the primary characteristics of the use case of the loads you're looking at before you decide which type of database management system, but also which storage specifically in that DBMS?
So it all again depends on the type of data what you will have. Like, is it more streaming data what you're playing with? Is it more transactional data what you're playing with? Is it something which is like a requirement of time series, effective time series data or something similar to that? Or you want to play with more machine learning stuff where you need a lot of compression done so that you can effectively read data. So these all depend on the type of use cases what you will have and also the ecosystem what you are playing with. So for example, if I'm in AWS, I would go for either Delta objects or Iceberg. I wouldn't even consider Hoodie because Glue has some integration with Iceberg now. And if I have to go with Azure ecosystem, then I would rather go for Delta objects because even Synapse and Databricks have certain integration with Delta tables. So these kind of different nuances as well. But if I have, let's say, an on-premise platform with a Hadoop cluster running somewhere or something like that, I might even go for Hoodie files. So it also depends on the ecosystem, what the organization is actually on, and also the type of data what they want to process, and the ecosystem or the type of models they want to implement. How do they want to retrieve the data from that platform is also important. So there are a lot of things, like I can go into the technical details about, like Delta objects is really good for data versioning, or Iceberg is really good at partitioning because you have the metadata files and the manifest files and all these different types of things what you can actually layer when it comes to Iceberg. So there are so many different things which goes into this. Like if you want to have like asset transactions where it is completely consistent across your file structure, so Delta is really good for it. But when you have base which is like strongly consistent, eventually consistent, then you would want to have some other formats like Udi or Iceberg. So it purely depends on what kind of platform you are in, what kind of data you are setting, and so on. So every tool has its own format or like own pros and cons, but it purely depends on the use case, what you should use.
Yeah, when I'm looking at like transactional use cases, often also have an analytical component. So when I'm looking at, for example, a CRM, I also often want to give statistics, aggregations on top of those. How would you go about doing that? So do you tend towards adding an additional storage component for the separate use case, so for the analytics, and keeping the transactional database purely transactional to display the clients? When do you decide you need like an additional component, an additional data storage component to support the different use cases you support in your use case and in your application?
So let's say for CRM, it's like a huge segment itself. Let's take our example, like we use Salesforce as our CRM platform. Now, when we are actually using Salesforce, we tend to limit ourselves with the capabilities what Salesforce provides. You can connect visualization tools like your Tableau directly to the Salesforce data, but then again, you are then restricted to what Tableau can do, like how much calculation you can do on Tableau. And it's very limited of how much machine learning or AI models what you can run on your Salesforce data on Salesforce. So in those scenarios, you would want to pick the data out of Salesforce, put it in a separate platform where you can massage the data, where you can bring in other data sets from other different CRM platforms or NPS systems or your sales platform or your invoicing platform, and then bring them all together and then train your AI model on top of it. That's where you definitely want to pull the data out. Now, that being said, there is also a concept of poka-yoking. I don't know if you are familiar with that, which is like fail-safing your input screen, like reducing your human errors, like making sure that, let's say, if you have an account number or let's say a currency input where you put a value. So this is where we have seen the most errors being made because few of the countries use dot separators, few of the countries use comma separators for values and so on. And when you actually pull the data out of these platforms and then start processing it in a unified platform, then you tend to get so many different errors which you would have never anticipated. So what is very important is that you have a Pokayoke screen for your CRM where you reduce the amount of human errors, what is actually happening at the moment when the particular user is actually inputting the data to that platform. Now, the moment that happens, then you have to do less processing on your side to actually massage the data later on. So what I look into is first step is making sure that I reduce the human errors when, let's say, a user registration form is created for a customer for a web application or like a e-commerce website. How can I reduce the amount of errors what a customer will do when they are loading that data to that platform? And then it will be really easy for me to do cross-referencing of customer information from 5 different platforms because I know that the customer should have done the least errors in the input screen. And then pull the data to a platform, then massage the data, and then run my models, and then do effective reporting. So I would do very limited reporting on the CRM platform itself because I will only be limited to that CRM platform itself. I can't do cross-reference from other platforms, or I have to bring all the data from other platforms into this one single CRM system, which usually is not supported, like Salesforce at least doesn't allow you to do that. You need a party location or another location where you can actually join these data sets together.
So in the end, the poker yoga is basically a mechanism. And if we are looking at the broader scheme, like poker yoking, how do I actually integrate that into my own system? Because we are working mostly with unstructured data nowadays. And I cannot really add like a screen or some input controls like I can, for example, if a user is entering a value in a form. How would you integrate something like poker yoking in your data ingestion system or data extraction systems?
So it all depends on how well you build your front end application. So as you mentioned, user registration. Like if there is like a Google login button or like a Facebook login button or a LinkedIn or a GitHub login button, then the fields get auto-populated and you know that a human is not actually entering the data, but whatever data which has already been provided to this third-party tool, you get that information. So you know that you can have less amount of quality checks implemented on top of it. But if a user is going like sign up with your email and you have a separate form what you need to go to, that's where like how you do password strength control, like you need to have like a capitalization, you need to have numeric value, you need to have a special character and so on. You can have similar kind of controls on your simple name field as well. Like you cannot have, let's say, a family name empty, or you cannot have your email address with, like, let's say if your email address is @hotmail.com, you cannot have @coldmail.com. I'm just randomly giving an example, right? So you will trigger like an email verification or like a phone number verification stuff and so on. So basically what Pokayoking means is like you build your front end application so well that there is least amount of information which the user can input incorrectly. That is step number one. And we have also realized that it also depends on the design of the web page or the front end application as well. So there is a sweet spot of around 35 to 40 seconds, where if a user sees that it can finish the entire form in 40 seconds or less than 1 minute, they will actually give the correct input. But if the user sees that I have to spend more than 1 minute or 45 seconds, basically, then they will just either enter AAAA or like some random character and then skip fields and so on. And that's where you start having the problem. So it also depends on how well you actually design your front end application to make sure that you have proper data quality. And the better data quality you have, the better your CRM platform is going to be.
Yeah. And for me, I also apply the same in the end for the data I'm aggregating. So if I'm working with PDF files or unstructured data, I'm basically enforcing the business rules, which are set from the top, or the data quality rules directly on the data. So when I try to extract names, I try to validate it immediately. If I'm extracting something like dates, I normalize all of it just into UTC, and all of my data processing, all of my data storage use the same time zone information. So all based on UTC. And the user still, if we have a user interaction as well, can enter it in his own time zone, but his entries basically are normalized into the backend, into UTC. So I have like a unit schema, which is imposed on all of the data which I'm working with.
Exactly. But it's easier for us to say when we are actually having like small development projects or like even small scale organizations working with 5 different locations, you can actually normalize it. The complexity comes when you, let's say, are working in a multi-nation large organization and you have to adhere to data compliances from every different region, let's say an Australian region or like Middle Eastern, European GDPR, or California State Data Protection Act, whatever it is, that's when the complexity comes on how you store the data locally first and then bring it all together. Because you, let's say, for example, GDPR, since we are both in Europe, we can't really move the data out of Europe. Or we'll have to first encrypt the data or sanitize the data before we send the data out from our Europe data centers to, let's say, US or India or Australia. So we will have to do that sanitization of data or encryption of data before we send it out. So that is also a type of normalization what you'll have to do.
Yeah. And maybe to close it out a little bit, you mentioned already when we talked before, it's like you have strong opinions. So I hopefully get them out of you now. So what solutions would you love to see more people adopt? And what solutions do you think are really overhyped at the moment and you would love to see not being used at all?
Strong opinions, I would definitely say first, Snowflake is overhyped. It is really, really good to actually use Snowflake when you are less technical and you want to have a feeling of how cloud data warehouses work. That's when Snowflake is shines. But the moment you want to load a lot of data to Snowflake and try to join tables, that's where you would see the cost exponentially increase on Snowflake. And that's where you would want to use something like Databricks instead of Snowflake. And I really, really like how Databricks right now is trying to improve its SQL capabilities and making sure it's more friendlier to use for like less technical people. So for me right now, Snowflake is definitely overhyped. Databricks is something which I would definitely want more people to use. But again, Snowflake has its own market as well. So you definitely see less technical people using more Snowflake, which is good. And now it is also getting there by the introduction of Snowpipe and other different ecosystem products of Snowflake, which is actually helping Snowflake be more effective when it comes to heavy data processing and be more cheaper in doing that. But I have seen people spend $10,000, $20,000 in a day when they try to process huge amount of data on Snowflake, and that's expensive. I can do that in a fraction of a cost on Databricks or even on a Synapse platform. I can do that in a fraction of a cost.
And maybe a quick follow up. What solutions or tool would you love to see built in data or AI that would really improve your life and your day to day work?
Automated referential integrity, if that made sense. Like, how can I join different data sets together with the least amount of time spent in identifying what the data actually means? From CRM platforms to your Google Analytics data or your information of user activities and so on, how can I join the different data sets to identify, let's say, a customer 360 view automatically? That is something which will be really, really useful for a lot of different industries. I have seen organizations try to do that, but they haven't really managed to do it successfully yet. They are working towards it, but I would definitely want more competition in having those kind of platform where you just plug in your different systems and then it creates like a 360 view for your customer or your patient or whatever specifics of that industry is.
So you just want your automated primary key and foreign keys so you can do the choice.
Yes, you can oversimplify it by saying that primary key and foreign key, but it is actually more complicated than that because let's say, as I mentioned, the Poka-yoking system, like what if a user actually, like, let's say you're Nikolai, and in one of the platforms you sign in as Nicolay, and the other platform you sign in as Nicolai. You are both the same person, but my foreign key join will actually fail if I try to join it with your first name basis. So you need like a fuzzy matching kind of stuff as well integrated in your platform so that I know that LAY and LAI are actually the same person by not just joining with your first name, but also adding your email address in the join condition, adding your phone number or your location, or sometimes, let's say in Apple login, you can actually mask your email addresses. So every single platform what you're joining will have an alias of your email address which is generated by Apple. So how do I still be able to join the two Nikolais together if you have logged in with your Apple ID and opted not to share your email? How can I still join the two Nikolais together? That's an art.
Yeah,
And that's where,
where you have to
yeah,
put something like confidence markers on different pieces of information, like how much confidence do I
exactly.
place in just the first name, how much confidence do I place in the first name plus the last name, and then actually like how many bits of information are necessary to represent a person. I think there was something circulating out there, and I think if you break it down into like more informative categories, like first name and last name are way more informative than gender, for example, and you can already reach like 90-95% accuracy with like three good pieces of information.
Exactly. But one last closing point when we are talking about these genders and stuff, you would see in a lot of these platforms when you build a user input form, even in gender, you may have unspecified. Like, I don't want to specify my gender. And how do you then join it? In one platform, you have declared that you are a male, or you have declared that you are a female. And another platform, you said that I don't want to specify my gender, or differently sort of that. Then how do you bring in the data sets together? And then how do you actually have these confidence markers enabled? Because again, the first name, last name matches, but your gender field does not, or your location. Then even your IP location tracking or your system MAC address can also play into a huge factor here, because a lot of systems actually capture the exact MAC address of your device from where you have actually registered. So that also plays a very key role.
Yeah. So when people want to follow along with you, what you're doing, and especially also what you're writing, or get in touch with you, where can people follow you?
LinkedIn, Medium. So I'm very, very, very active on Medium. I try to write one article every month. So you can reach out to me on LinkedIn as well. So I'm pretty sure, Nikhil, you are going to share the LinkedIn information as well. So Medium, LinkedIn, these are the two forums where you can definitely reach out to me.